So on the Friday before we left, I did a quick lecture. Well, it wasn't quick, but we did a lecture over how to do some conversions, introducing them. Hopefully what you found earlier this week was relatively straightforward. Now we're going to make the jump into the conversions that we're going to deal with for most of the rest of the year, and that is dealing with a unit called mole and grams. So let's see where that relationship comes from first, and then we'll show you how to use those. So on the periodic table, if we look up magnesium, magnesium has a mass of 24.31. As we know now that represents an average mass for all the different isotopes of magnesium. So the first step we're going to do in looking at these relationships is we're going to convert that mass into grams. So if I have 24.31 atomic mass units for magnesium, if I want to convert that into grams, I have my conversion here. 1 atomic mass unit is going to equal 1.6606 times 10 to the negative 24th grams. Using our significant digit rules, and obviously we're going to use scientific notation on this, the answer that we would get would be 4.037 times 10 to the negative 23rd grams for magnesium. So what this represents is that this is the mass in grams of one atom of magnesium, in atomic mass units, and this is the mass of one atom of magnesium in grams. Now, scientists don't deal with, and chemists don't deal with individual atoms on a daily basis. We deal with larger quantities. So we need to have a way of being able to use this number, this 24.31, but have it something that we can measure in the lab. And what scientists did is they found out that there's a relationship that we can use to make this number here equivalent two ways. If we look at and say, okay, I've got 6.022 times 10 to the 23rd atoms of magnesium. If I want to know how much that weighs in grams, we kind of have a conversion up here on the board. What we're saying here is that one atom of magnesium is equal to 4.037 times 10 to the negative 23rd grams of magnesium. So I can use this as a conversion factor and say, okay, if I've got that many atoms of magnesium, for each atom, I've got 4.037 times 10 to the negative 23rd grams of magnesium. And when you calculate that out, you get 24.31 grams of magnesium. What this means then is that 6.022 times 10 to the 23rd atoms of magnesium is equivalent to 24.31 grams of magnesium. The importance here is that this unit right here is 1 mole. So this value for one atom of magnesium weighing 24.31 atomic mass units, that's for a single atom, we now have a number equivalent to 24.31, but representing a large sample of magnesium atoms, and it's 24.31 grams of magnesium, is that many atoms of magnesium, but we would say it as 1 mole is 24.31 grams. So I'm going to write a list of conversion factors here that we can get from these relationships. We know that 1 atom of magnesium is equal to 24.31 atomic mass units of magnesium. We know that 1 mole of magnesium is equal to 6.022 times 10 to the 23rd atoms of magnesium. We know that 6.022 times 10 to the 23rd atoms of magnesium is equal to 24.31 grams of magnesium. And by default then, we know that 1 mole of magnesium will equal 24.31 grams of magnesium. Basically, what we're looking at is if A is equal to B and B is equal to C, then A is equal to C. And of all of these conversions that I have written on the board, this conversion right here is the most important one that we are going to use in several different ways. When you look at a periodic table then, you are looking at this mass representing 2 things. The mass of one individual atom in atomic mass units, or you are looking at it as 1 mole, a large sample, this many atoms of that element equaling this many grams. And because we deal with these large samples of atoms, this is the unit of conversion that we will use on a very regular basis. We are not going to use this on a very regular basis. You do not need to memorize this number. I will give it to you whenever you need it. But this will be the focus of what we're going to move on with